Good afternoon and welcome back. This is episode 2 of Learning Rust. So we're going to be going through this book. I believe last time we went through programming a guessing game. Just going to verify here. Go to the end. At this point, built a guessing game. The project was hands-on way to introduce us to many new Rust concepts like let and match methods, associated function, use of external crates, and more. Right? I think this was all covered. Yeah. Yep. So let's go ahead and look at chapter 3. So this is going to be common programming concepts. This chapter covers concepts that appear in almost every programming language and how they work in Rust. Alright, so many languages have much in common at their core. None of the concepts presented in this chapter are unique to Rust, but we'll discuss them in the context of Rust and explain the conventions around using these concepts. Learn about variables, the types, functions, comments, and control flow. Okay. Rust language has a set of keywords, as do every language, that are reserved for use by the language only. Keep in mind you cannot use these words as names of variables or functions. Understood. Okay. As mentioned in chapter 2, by default variables are immutable. You have to specify immut to make them mutable. We remember that. This is one of many nudges Rust gives you to write code in a way that takes advantage of the safety and easy concurrency that Rust offers. However, you still have the option to make variables mutable. Let's explore how and why Rust encourages you to favor immutability and why sometimes you might want to opt out. When a variable is immutable, once a value is bound to the name, you can't change its value. Alright, to illustrate that, let's create a new project called variables. Okay? So we will do that. Let me force quit this. So cargo create, cargo new variables, and we'll cd into variables. Make that a little bigger. A little bigger. Okay. Open main.rs and replace its code with the following code that won't compile just yet. Okay. cd to sure. Okay. So we want to paste this code and get rid of all of the other code. Alright, let's try to understand why this wouldn't work, because x is declared up here and we didn't specify mutex. So if I specify that and then we cargo run, this will work. Okay, plug in my laptop here. Okay, so yeah, that worked because we set the mutability. If we were to not set the mutability and run that, then we see cannot assign twice to an immutable variable. Okay. We get compile time errors when we attempt to change a value that we previously designated as immutable. Understood. If one part of our code operates on the assumption that a value will never change, and another part of our code changes the value, it's possible for the first part of the code won't do what it was designed to do. The cause of this kind of bug can be difficult to track down after the fact, especially when the second piece of code changes the value only sometimes. In Rust, the compiler guarantees that when you state that the value won't change, it really won't change. This means that when you're reading and writing code, you don't have to keep track of how and where the value might change. Thus, the code is easier to reason through. But mutability can be very useful. So, in Chapter 2, we learned that you can make them mutable by adding mute in front of them. In addition to allowing this change, the immut keyword conveys intent to future readers of the code by indicating that other parts of the code will be changing this variable value. For example, we add immut and everything works. Difference between variables and constant. Being unable to change the value of a variable might have reminded you of another programming concept that most other languages have, constants. Like immutable variables, constants are values that are bound to a name and do not allow change, but there are a few differences between constants and variables. First, you aren't allowed to use immut with constants. Constants aren't just immutable by default, they're always immutable. That makes sense. You declare constants by using the const keyword instead of let, and the type of the value must be annotated. Oh, I like that. We're about to cover types and type annotations in the data types section, so don't worry about the detail right now. Just know that you must always annotate the type. Got it. So constants must be annotated. And this looks to be an annotation here with the colon. Constants can be declared in any scope, including global, which makes them useful for values that many parts of the code need to know about. The last difference is that constants may be set only to a constant expression, not the result of a function call or any other value that could only be computed at runtime. Okay. Here's an example of a constant declaration where the constant's name is maxpoint, its value is 100,000. Oh, interesting. Rust's naming convention for constants is used in all uppercases with underscores between the words. Okay. Constants are valid for the entire time the program runs within the scope they were declared in, making them useful choices for values in your application domain that multiple parts of the program might need to know about, such as the maximum number of points a player of the game is allowed to earn, or the speed of light. Naming hard-coded values throughout your program as constants is useful in conveying the meaning of the value to future maintainers of the code. Sure. Shadowing, as you saw in the guessing game tutorial, you can declare a new variable with the same name as a previous variable, and the new variable shadows the previous variable. Rustaceans say that the first variable is shadowed by the second, which means the second variable's value is what appears when the variable is used. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. Interesting. Is that not mutating it? Let's do that. We'll just do this one. So we'll build that, and we built it. Did I not output anything? I did print line. The value of x is x. I didn't see that though. Cargo build, I thought. Cargo run. Sorry. There we go. Okay. When I built it, it made a target folder, and I'm going to delete. Yeah. Okay. Shadowing is different from marking a variable as mutable because we'll get a compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let, we can perform a few transformations on the value, but have the variable be immutable after those transformations have been completed. The other difference between immutability and shadowing is that because we're effectively creating a new variable when we use the let keyword again, we can change the type of the value, but reuse the same name. For example, say our program asks the user to show how many spaces they want some text by inputting space characters, one between some text. But we really want to store that input as a number. Oh, interesting. Okay. Could I not just len the string? Anyway. I feel like I could. Anyway. This construct is allowed because the first spaces is a string, the second spaces variable, which is a brand new variable, happens to have the same name, is a number type. Shadowing thus spares us from having to come up with different names, such as spaces string, spaces num, etc. Instead, we can reuse the simple spaces name. However, if we try to immut for this, as shown here, we'll get a compile time because of the type. Because we're not allowed to mutate the variable's type. Okay. Interesting. So that's shadowing. Every value in Rust of a certain data type, which tells Rust what kind of data is being specified, so it knows how to work with that data. Every value in Rust is of a certain data type. Yep. Keep in mind that Rust is statically typed language, which means that it must know the types of all variables at compile time. The compiler can usually infer what type we want to use based on the value. Any particular reason why I'm learning Rust? I've been interested in Rust for a while. I'm looking for something to use instead of C++ when I'm working on lower level projects, and just has seemed interesting. So I wanted to get into it and learn it, and also with the intention of teaching others what I learned through a series of videos on this channel. Okay, so we've got a statically typed language. In cases where many types are possible, such as when converted to a string to a number type using parse, in comparing the guess to the secret number in chapter 2, we must add a type annotation. Okay, so we've got type annotations here. We want it to be a uint32, which means we have to do this string parse to uint expect, which is like accept. I don't know why they call it expect. Expect it as not a number. So let's add this real quick. Yeah. Then this, we'll just paste this in here. So we'll have two. And because I'm using let, I can shadow it, and both should work. And I can change this to ASDF, save it, and we'll just create a new one down here. What's the complaint? Unused variable guess. So we can then say, I think, exclamation print guess. I think that's how that goes. Is it print? Format must be a string literal. Let's see. Rust lang print. Print ln. I think I could do like this. Yeah. Yep. Exactly. Okay. And then it's mad, so I gotta do that up here, and then it should be fine. Expected. Oh, semicolon based language. I've been doing a lot of Go, so I'm going to be dropping off semicolons a lot. Alright, so let's run that. So cd to learn Rust, variables, and then we will go run, or like I said, too much Go lately. So Rust, which is cargo, run. Not a number, panicked. And did we see the actual number? Or did they both panic? I would have expected this. Oh, there. I need to print ln. So we'll undo that. And there we go. So that is what I expected. If we don't add an annotation here, Rust will say type annotations needed. Let's see. In cases where many types are possible, such as converted string. Okay, yeah. I believe that makes sense. Alright, so a scalar type represents a single value. Yep, Rust has 4 primary scalars: integers, floats, booleans, and characters. May recognize these from other languages. Integer types. We got 8, 16, 32, 64, and 128-bit integers. And then we can have signed, which I for integer, or unsigned, U for unsigned integers. These are going to be positive only. These are going to be positive and negative for 8-bit. Okay, and we're going to learn which direction is supported. So each variant can be either signed or unsigned and has an explicit size. Signed and unsigned refer, leaving out the semicolon in Rust is implicit of a return of a block. Okay, interesting. So this, technically that would work, and it does. Okay, so if I were to get rid of that guy, then we would have expected semicolon. Interesting. I wonder why that is. Probably just so when you do this, technically this line is here. Oh, oops. There we go. Yeah. Okay. Good news. Okay, each signed variant can store numbers from -2 to the n minus 1 to 2 to the n minus 1 inclusive, where n is the number of bits that the variant uses. So let's mess with this, right? So we would want an I 8. Yeah. So let my number annotation. I guess I would want an I8, and then it's just equals 250. Well, let's see what happens with that. Oh, I kind of figured that would allow it. I guess I was wrong. And then I can print line my number. Right. Okay, and then it's going to say should have snake case. Okay, yeah, out of range. So technically, 1, 2, 3, 4. Is that right? Yeah. I don't know. Oops. Oh gosh. What's the limit here? Yeah, 127. Okay, and then we'll do this again. I negative 127. 28. Yeah. And that's out of range. Okay, so yeah, there you go. So if we were to run this, we would see that we can at most have 127 positive on an I8 and at least have 128. So if you are to add those together, you end up with, so 127 plus 128 plus, yeah, and that includes 0, which would just be none of them. And in other words, the binary would be like that. So it's a free bit, essentially. Free byte, I guess you could say. All right, so that makes sense. So we can have more on the negative than on the positive by 1. Yeah, -2 and -1, -1. Okay, that makes sense. So a unsigned integer can store 0 to 2 to the 8th minus 1, which is 255. Additionally, the I size and U size types depend on what kind of computer your program is running, 64-bit or 32-bit. And that's for integers and unsigned integers of the size of the architecture. You can write integer literals in any of the forms shown in 3.2, which is below here. Okay, note that all number literals except the byte literal allow a type suffix, such as 57U8, and underscore as a visual separator, such as 1000. Okay, so let's play with this idea. Decimal 98,222, maybe? Let decimal equal, decimal, do I have to specify? We'll just say decimal, because it only has one type it's going to be, I think, so it should not require an annotation, if I understand that correctly. And then print line decimal. It's going to take me forever to get used to that. It needs a string literal and an argument passed in. Hey, how's it going? Emmanuel Paul? Nice to see you. We're just learning some Rust right now, and I am learning basically the data types that make it up. So these look to be optional, but I can specify, like, I can't specify a comma. This comma is interpreted by the interpreter as basically some other token. And I can't just wrap it in quotes because then I get a string back, right? So rustlang get type. So what is this? Okay. Well, how do I get a type? How do I print the type of my number? If you merely wish to find out the type of a variable and are willing to do it at compile time, you can go as an error. I don't totally want to do that. Unstable function. That can get you the name of the type. Interesting. I guess I'll just cause an error. There doesn't seem to be a way to easily get the types. Invalid method. I'll do that. Decimal dot learning. Okay. A method named learning for type string. So that's where we find out the string. So if I want it to be, and let's see what happens. Here we get unexpected comma. So if we just define it without anything, we'll get type integer. And if we define it with an underscore, we should get integer. Yeah. So this is just a readability token. Okay. So, okay, as a visual separator, hexadecimal, octal types, binary types, that's very good. I like that. And a byte, which I assume is going to be an ASCII byte, which would go into like the ASCII table. And it would basically be, if I wanted A of ASCII type, that would be decimal 65, hexadecimal 41, octal 101. Okay. U8 only, so it's going to be an 8-bit byte. So no UTF-16. Okay. So how do you know which type of integer to use? If you're unsure, Rust defaults are generally good choices. And integer types default to I32. This type is generally the fastest, even on 64-bit systems. Primary situation in which you'd use integer size or unsigned integer size is when indexing some sort of collection. Integer overflow. Let's say you have a variable that's an 8-bit unsigned integer that can hold values between 0 and 255. If you put a range such as 256, you'll get integer overflow. So that would be like unsigned 8. And I did 256. Oop. 256. Yeah, absolutely. Feel free. Code buddy. Yeah, definitely always need code buddies. It's pretty essential. And that's one of the big reasons I want to do these streams and this channel, is it's much easier to learn together. But I can't teach if I don't know, so I need to learn Rust so I can better teach it. Okay, so 256. Why is this happening to me? 256. Weird. Okay, so we get a literal out of range for I8 or U8. When we run this, we see out of range, aborting due to previous errors, overflowing literals, deny overflowing literals. So I could not deny this and we could see what happens, which I'm very interested in doing. So let's see, allow overflowing literals Rust lang. Because of the move programming to LibreCoin. What do you mean? Is LibreCoin related to Rust? Oh. Look at that. I didn't know that. Libre source code is written in Rust and published as open source. Let's go ahead and go to Libre Crypto GitHub. Look at that, 100% written in Rust. Yeah, I mean, that would be a great reason to get into it. And really just, Rust seems like a really good language for cryptocurrencies in general. Just because you're dealing with very high performance code, because you're very specific about the types. Yeah, and you're operating on a lower level, so there's less sort of abstraction, and you're relying a lot on compilation and getting it down to, I'm not sure if it goes to byte code or if it goes to machine language. Okay, so cool. I'm going to have to check that out. Oh, I'm not signed in on this computer. That's all right. I'll make note of it in the show notes, which I can create. We're going to touch show notes.md. And I'll just leave that in here. And this would be like, I think like that. We'll say Libre is written in Rust. Cool. All right, so back to what we were learning. Yep, so you'll get an integer overflow. Rust has some interesting rules involving this behavior. When you're compiling in debug mode, Rust includes checks for integer overflow that cause your program to panic at runtime. Rust uses the term panic when the program exits with an error. We'll get more into that into chapter 9. When you're compiling in release mode with the release flag, Rust does not include checks for integer overflow that cause panics. Instead, if the overflow occurs, Rust performs two's complement wrapping. Short's value greater than the maximum value the type can hold wrap around to the minimum of the values the type can hold. In the case of a U8, 256 becomes 0, 257 becomes 1, and so on. The program won't panic, but the variable will have a value that probably isn't what you were expecting to have. Relying on the integer's overflow wrapping behavior is considered an error. Yeah, I agree. If you want to wrap explicitly, you can use the standard library type wrapping. All right, hey, thanks, Emmanuel. I'll see you later. All right, so that makes sense. It's interesting. I'm not sure how I feel about that. I'd almost rather it wrap in dev mode as well, but I get why it doesn't, because it's considered an error. But if you ship with the error, it's going to do everything it can not to panic and crash, and so it's going to wrap. So you should catch it in debugging in development mode and never have it be a problem on production. Okay, so Rust also has two primitive types for floating point numbers, which are floating 32 and floating 64. Default type is 64 because on modern CPUs it's roughly the same speed, but it is capable of more precision. And if you don't know about the math that that floats operate on, it's pretty interesting, and this will probably not go into it. So 2.0 is 64, but you specify float 32, and 3.0 is accurate, but to less precision. So we'll say 32-bit float versus 64-bit float. Let's see if they show. Okay, yeah, perfect. So in 64-bit, dividing by 3 is equal to this many decimal places, and on 32 you only get to here, right? So just by having 64-bit, you give yourself a huge amount of precision that you wouldn't see in 32-bit floats. So, all right, that makes sense. Rust supports basic mathematical operations: plus, minus, multiply, divide, modulus. Wait, what? It doesn't support exponents. We're just gonna go here. Uh, 2 to the power, we'll say 5, yeah, and then we'll just print line string token remainder and you know what, we'll just get rid of addition as well. Cargo run. I was like, it's like it added. What if we double multiply? Oh, right, so that'll be a reference. So that'll work. And that'll work. What? Exponent. How do I put, yeah, power? You don't need num crates nor do you need import, just use power directly. So 2 to the power of 5. No, not happy about that. I want it to be an unsigned 32-bit integer. Rust lang power of 2 to the power I have to specify like let x u int 8 equal to x to the power, oh sorry, u8. Okay, but I can't just say 2. On it. What if I say u8? Okay, interesting. So I'll have to get used to that. Okay, cool. Boolean type, true, bool, false, explicit type annotation. I'll probably mostly be using these. No reason not to, in my view. Character types. So car literal specified with single quotes as opposed to strings, so they're like runes in Go. That makes sense. First car type is a 4 byte in size and represents Unicode scalar value, which means it can represent a lot more than just ASCII. Ah. Accented letters, Chinese, Japanese, Korean letters, emojis, and zero with spaces are all valid chars in Rust. Unicode scalar values range from Unicode 0 to hexadecimal inclusive. However, character isn't really a concept in Unicode, so human intuition for what a character is may not match up to what a char is in Rust. We'll discuss in Chapter 8. Compound types. Compound types can group multiple types into one type. Rust has two primitive compound types, tuples and arrays. Tuples are probably going to be immutable like they are in Python, but let's find out. Tuples are a general way of grouping together some number of other values with a variety of types into one compound type. Tuples have a fixed length. Once declared, they cannot grow or shrink in size. We create a tuple by writing a comma-separated list of values inside parentheses. Oh, okay, so we specify at which index in the tuple we're going to have the type, and then we specify the types. That's weird. Okay. So they're almost like structs in a way. Variable tup binds the entire tuple because the tuple is considered a single component element. To get the individual values of the tuple, we can use a pattern matching to destructure the tuple value. Okay. So let's play with this. Okay, so we'll say x, y, z, x, y, z, and then we can say type U16, float 64, and U8. Okay, so that has to be inside of parens. Okay, and then on the way out, so this should work, cargo run, and then on the way out, we can also be explicit, I assume. Although I don't really know, but this seems reasonable. No, you cannot. Can we do it over here? And basically, we are yoink around these, and then just paste those. No. Ascription, type ascription is experimental. I don't know what that means. I must be doing something odd. Okay, so first creates a tuple, binds it to the variable tup, and then uses a pattern with let to take tup and turn it into 3 separate variables, x, y, z. This is called destructuring because it breaks the single tuple into 3 parts. Finally, the program prints y. In addition to destructuring through pattern matching, you could do it like this. Let. Okay, yeah, that makes sense. Thank you. All right, so got it. Okay, so we could basically just yank around this, paste it, and that's valid. Got it. That makes sense. Cool. Aye, Rust indeed, Rust indeed. Yep, so I'm pretty much brand new to Rust, so I'm learning the syntax and the semantics, and I'm just going through the Rustling book chapter by chapter and sort of chronicling it on this stream. So if you're interested in that, throw a follow at me. I also do katas in Rust and Go, and really any other language that people are interested in. Yeah, you might learn something new. I generally don't go through books like this when I'm learning a programming language, but I really wanted to be thorough about this and sort of document it and take people along with me on the journey. If one gets rusty at Rust, does one become better? I'm gonna say yes. I'm gonna assume that's true. Just add water. Yeah. Okay, so this creates tuple x and then makes the new variables from each element, right? Makes sense. As with most programming languages, first index is 0. Another way to do this is to have an array. Unlike a tuple, every element of the array must have the same type. Thank you. I'm so glad to hear that. Arrays in Rust are different from arrays in other languages because arrays in Rust have fixed length. Oh, really? Like tuples. So that's interesting. So what if you need to expand or append to your array? Do you have to, oh, you would shadow it, I would assume, and concatenate. Use a vec. Okay, I'll learn about vectors here in a minute, I think. Oh, I think I just saw it in there. So, yep, let's go through this. In Rust, the values going into an array are always written as comma-separated list inside of brackets. Useful when you want your data allocated on the stack rather than the heap. Okay, we will discuss those in chapter 4, or when you want to ensure you always have a fixed number of elements. An array isn't as flexible as a vector type. There we go. Vector is similar to a collection type provided by the standard library. Oh, is a similar collection type provided by the standard library that is allowed to grow and shrink in size. Kind of like a slice and go, I suppose. If you're unsure whether to use an array or a vector, you should probably use a vector. Yeah, well basically if you are mutating it over time and appending or popping, then vector. Okay, so an example of when you might want to use an array rather than a vector is in a program that needs to know the names of the months of the year. It's very unlikely that such a program will need to add or remove months, so you can use an array because it will always contain 12 items. Sure. Okay, so you specify the type and the length, and then you populate it. Okay. And this would be, okay, so breading an array's type this way looks similar to an alternative syntax for initializing an array. If you want to create an array that contains the same value for each element, you can specify the initial value followed by a semicolon and then the length. Got it. So like, let's play with this. All right, so we're just going to do A. All right, so how do you print an array? Do I have to like, if you want? Okay, I think you could do 3 of uints. Yeah, that makes sense. 3 of uints, 5 for the length if you want 3 or unsigned 8-bit integers. Let's do rustling print array. Probably gonna have to. Oh. Print. xn print each one. I want to print the whole thing. Yeah, they're going to say JSON it. Or toString it. Can I toString this? Let's look up rustling array. I guess it is this, huh? Do we have like methods on it? Trait implementations. Yeah, I'm not familiar with those yet. Okay, we're not going to worry about it. It will get there, I'm sure. Use literals. Golang array literals. Oh yeah, yep. That would work. Oh, sorry, rustling. Arrays and slices. Would that print them though? See, they're just printing slices, like indexes. All right, so basically I want to print the length, or A in the length of A minus 1. How do we do rustling len of array? Len. Okay. So then if I said okay, so this would be 3, 3, 3, 3, 4. I already forget how to define the actual size. Okay, got it. So you're saying like 3 of, yeah, that makes sense. So I want just a U8, 5, is that equals? Equal to 1, 2, 3, 4, 5. Because array implements, oh, you can use a.last. Okay. I definitely could. I'm not sure that I'm going to. Let's see, what did we get? Expected value, not a value. What am I doing wrong? Let this out. Oh my gosh. Okay. Right. Or I could just do dot last. Dot unwrap. I'm not sure why that works yet, but it sure does. Okay, so because array implements the debug trait, you can print colon question mark for 6, or in your case, print A. You should avoid specifying types. Okay. Why? Not sure what that means just yet. How do you, I'm just going to call you Octopus. One, and so you're saying basically that this would cascade the type of U8 through here. Yeah. Oh, that'll output the whole array pretty printed. That's what I was looking for. So I'm not sure why yet. But usually this is like splitting from one side to the other. So I would imagine beginning to end of this. There we go. And if we wanted, you'll learn what debug is later with traits. Yeah. Yep, I'm confident that is true. Cool. And then again, if I wanted to create an error, would I see my type? No. Yeah, I'm having a hard time actually figuring out if I can like print the type that a variable is. So like if I were like wanted to see the index of array at index 0 and what type it was, could I do that? And in a tuple, could I see it at various indexes? So anyway, access them by index 0, index first, invalid array access element. What happens if you try to access it? I imagine we're going to get an error. Right? Yeah. Unoptimized, debug info targets, index out of bounds. Right? So we're going to always have to check if our index is within the length of the array. Okay. Compilation didn't produce any errors. Okay, so where are we at? So we're only at data types, so we got plenty more time here. There are IDEs that will add annotations into your code to show you inferred types. IntelliJ with Rust plugin. Do I have Rust? I have Rust Vim. Type. Documentation help Rust. No, and I generally don't need to print types either. I'm just kind of looking to verify my ideas while I'm learning. Type. Expands the current file using pretty. Type. Okay. EverX80 says, and to know, oh, for me, when I was learning, it was nice to see. Same, that's where I'm at. And to know that what you think is going on is actually going on. Yeah, you can't print type without intrinsics. It requires unstable. Yeah, I was looking at that. I'm not sure what intrinsics. Intrinsics Rust lang. Oh, compiler intrinsics. Volatiles. Volatiles intrinsics provide operations intended to act on input-output memory, which are guaranteed not to be reordered by the compiler across other volatile intrinsics. See the LLVM documentation. It sucks. Rust is a bit slow to this stuff. Yeah. That's why an IDE can do it. Makes sense. Not everyone likes IntelliJ. Bit heavyweight. It is a bit heavyweight. I actually love IntelliJ in general, but I've gotten so used to being able to navigate around with Vim that unless I'm doing like debug stuff, which this would be a perfect case to be doing debug stuff, I don't open up IntelliJ. So I think I'm just going to keep with Rust and Vim through this. Yeah, I know. It does have a Vim plugin, but it doesn't offer the true modal editing. Like, you don't get buffers, right? And a lot of my patterns rely on buffers, so I can be like, go to, my vimrc, and then I can delete the buffer. And then I can just vertically split, and then I can use tmux, and I can have all my splits in tmux. And then I can just run my tests from here, and so on and so forth. So I just decided to stick with Vim for the time being. It's really just preference, I think. Yeah, let's focus on the mission. You're right. So let's go ahead and close down all this research. And I'll get into intrinsics, and I'll get into unstable and everything as this book sort of progresses. We have a long road ahead of us. All right, so where were we? We were at the tuple type, the array type. Let me close this out. Okay, yeah, so we had finished this chapter. So next we're going to get into functions. I think I'm going to finish out, let's see what time it is, 12:15. I got about 45 more minutes I can stream. So functions are pervasive in Rust code, as they should be. You've already seen one of the most important functions in the language, the main function. Entry point, you've also seen the fn keyword, which allows you to declare new functions. Rust uses snake case as conventional style for functions and variable names. In snake case, all letters are lowercase and underscores to separate words. Here's a program that contains an example function definition. Cool. Because another function is defined in the program. I mean, I'm going to assume most people know about functions, but basically you can have an unlimited amount of them in your files. We're going to have parameters passed in. We can specify the type like you would anywhere else. And it'll interesting. So let's do something here. So other function takes in x, and we're going to have that be an unsigned 32-bit integer, and then we're going to print line for x, and then up here we're going to have we're just going to call it a, and it's going to be an unsigned 8-bit for 5, and then we're going to call we need to let this, and then we're going to call other function and pass in a, and I would predict that this should error, but it might cast it. Aha, okay. So yeah, mismatch types, so I would have to specify 32 here, and that would work. Unexpected. Okay. And then if I did 8-bit here, error, and if I get rid of the type, it's fine, and 64 would be fine. So it's going to do some introspection at compilation level, and it's going to see where a is used. And because a is used where it is passed in as a 64-bit integer, it's going to instantiate it as that, which means if I had another function that takes x as an 8-bit and then prints x, and we said another function a, I would expect an error probably on, I don't know which one, it could be either one. There, the latter one. Okay, and it says, hey, we expected an 8-bit, but because this was called first, we got a 64-bit, and I think it was because it was called first. So now other functions should error, yeah. So it's not about the order of these, it's the order of this call that dictates the type of this let. unless I were to be specific and say you ate, and then the first one would fail, and the second one would succeed. Okay, that I understand. Yeah, cool. Try running this program, you should get the following output. Yep. Yes, it's the first usage that restricts the type. Yep, makes sense. Okay. And it's probably going to go into the declaration of all that. I understand that fully. Function bodies contain statements and expressions. They sure do. That'll work. Statements do not return values. Therefore, you can't assign a let statement to another variable. As the following code tries to do, you'll get an error. Expected expression found statement. Yep. Makes sense. I would never write code like that anyway. Okay, now here's something. So we've got an expression here, and inside that expression, so this gets into scope. So this expression is a block that, in the case, evaluates to 4. Let's play with this real quick. So x is 5, y, x is 3. So now we want to say x, y, and then print line x, y. So my prediction is that, so y cannot be found in the scope. And what's wrong here? Formatted default. Oh, because it's an expression. Wait, how are they doing it? That last semicolon in the block matters. Oh, because it's got to return x, right? Interesting. Okay, so anyway, then in that case, we would say let x equal x plus 1, and then we can just x, and then we can print line basically this. Yeah, and y is not in the scope. Does Rust have this scope? We'll find out in a minute. So basically, the goal of what I'm trying to see is that this remains 5, this becomes 4, and then we see 5, 4. Yeah. Oh, and I don't even see. No, yeah, that's right. Yep. And so just to verify, wow, I think everything is verified. Shadowing works as you would expect. Yeah, for here it does for sure. The main thing I was checking here is that the scope outside of this expression block means that this let is held within this scope, and it doesn't leak out post, and it doesn't take in the value from here, which I could verify with let z, and then I could try to print z and I would see that show. Yep. So scope goes in, but then why didn't, oh, because y is not yet declared, because we're in the expression itself. So y is going to not be available. Okay. So scope works inward, but not outward, and you can have overwriting of a higher level scope, but it won't overwrite the scope when you exit the block. Alright, so I think I need to understand why we don't need the semicolon. Is it a block? In this case, evaluates to 4. Note, without the semicolon at the end, which is unlike most of the lines you've seen so far, expressions do not include ending semicolons. If you want to add a semicolon to the end of expression, you turn it into a statement, which will then not return a value. Keep this in mind as you explore function, return values, and expressions next. So, turn it into an expression. Expressions do not include ending semicolons. If you add it, you turn it into a statement from an expression. So it's an expression without the semicolon, a statement with one. Okay, well, so we add one and we just say return x. And it complains. Expected, types expected. Whatever type that is, nothing I suppose. Return would return from main. Okay, got it. Could I do like an anonymous function? Anonymous function. Expected expression found keyword fn. Rustling anonymous function. Closures. Oh. Okay, so then that would be x result. Okay. Huh. And then I would have to do y. And then maybe let y equal y. Oh, now what? Unused arithmetic. Let x equal. Oh, I'll be right back. Okay. That is all taken care of. So now Z is not used, and this all works. Yep. Okay. I understand. So we want expressions as opposed. So delete 2 here. And then we don't need to do that. And then we just run our expression. Cool. Makes sense to me. So, all right. Back to functions. Functions with return values. Okay, returns this type. Type after the arrow in rest. The value of the function is synonymous with the value of the final expression in the block of the body of the function. You can return early from a function by using return keyword, but most functions return the last expression implicitly. Cool. Just return that. There are no function calls, macros, or even let statements in the 5 function. Just 5. That's perfectly valid as it gets cast to a I32. 5 and 5 is the function's return value. Yep. 5 has no parameter that, and defines the type of the return value. Okay, so takes the 32-bit in, returns a 32-bit. Okay, so let's see if I can figure out why this would produce an error. +1, 5, 32-bit int comes in, x plus 1, x is immutable. So, a couple of things we could do. We could, so first, it's already letting me know. Oh, it does not return. So it would have to be like this. Oh, and then it's not modifying x. Yeah. So we could either do that, or we could do return x. Oop. We could do x is equal to x plus, and then we get the immutable. And we could let to shadow, or we could mute here. Let's see. X cannot be assigned to an immutable argument. Ah, so we mute here? What about here? Okay, all right. So then it's X in a different scope. Okay. Oh, and then X gets declared here. Got it, got it, got it, got it, got it. Okay. All of it makes sense. Alright, so the main error message, mismatched type, reveals core issue with code. Function +1 says it will return, but it doesn't have a return because of the semicolon. The statement don't evaluate to a value, which is expressed by, okay, those empty as a no value. Therefore, nothing is returned, which contradicts the function. REST provides a message to possibly help rectify this issue. It suggests removing the semicolon, which I already did. Okay, what else do we have? Comments and control flow. Let's just finish this off. We've got time, right? 1, 2, 3, 4. Hey, look at that. Okay. Some programmers strive to make their code easy to understand. That's me. But sometimes extra explanation is warranted. In the case programmers leave notes or comments, forward slashes, you can do multiple forward slashes, you can do trailing forward slashes. Is that it? There's no block comment? Oh, sorry about that. I've got a needy dog right now. Okay, so yeah, there's block comments. We'll just follow this. Rust also has other kind of comment, documentation comments, which we'll discuss in chapter 14. Okay. Control flow. Ifs, no need for parentheses. Those are pretty straightforward. Value makes condition false, see what happens. If number. Rust throws an error, expected bool. The error indicates that Rust expected bool but got an integer. Unlike languages such as Ruby and JavaScript, Rust will not automatically try to convert non-Boolean types to Boolean. You must be explicit and always provide if with a Boolean as its condition if you want the if loop or if code block to run only when the number is not equal to 0. You can say not equal to 0. Okay. Handling multiple conditions, else if, which I try not to use them very much, but if, else if, else if, else. Program has 4 possible paths. Using if and a let. Okay. Because if is an expression, we can use it on the right side of a let statement. Number, if this condition, 5, else 6. Interesting. Okay. Block of code evaluate the last expression in them, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block it executes. You get an error, expected integer, found string, because of the first one. That makes sense. Repetition with loops. Rust has loop, while, and for. Loop, it'll go over and over and over again until you either break or go to, I just imagine. Quitting after a correct guess. Returning values from loops. Result is equal to loop counter if break. If counter is 10, break and return counter times 2, which would be 20. Conditional loops. While often useful for a program to evaluate a condition within a loop. While the condition is true, the loop runs. When the condition ceases to be true, the program calls break, stopping the loop. This loop type could be implemented using a combination of loop, if, else, break. You could try that now in the program if you'd like. No, thank you. Oh, the while, it's called the while loop. While the program loops 3 times. Yeah, yep. While number is not 0, decrement it to 0. Comment, looping through a collection with 4. So you could write while constructor loop over elements in collection. So you've got these index and then increment the index, but you could also just do a for loop for element in, okay, this is interesting. You can use a for loop and execute some code for each item in a collection. A for loop looks like the code in listing 3.5. When we run this code, we'll see the same output as 3.4. More importantly, we've now increased the safety of our code and eliminated the chance of bugs might result from going beyond the end of an array. Okay. For example, using a for loop, you wouldn't need to remember to change any of the code if you change the number of values in an array. Well, that's weak thinking, but okay. The type safety, or the safety and consciousness of for loops makes them mostly common for loop construction in Rust. Okay, the most common. Even in situations in which you want to run some code a certain number of times, as in the countdown example used a while loop. That used a while loop, I'm getting tired. Most rustations would use a for loop. The way you would do that would be to use range, which I'm familiar with, which is a type provided by the standard library that generates all the numbers in sequence starting from one number and ending before another number. Here's what a countdown looks like in the for loop, and another method we've not yet talked about, rev, to reverse the range. This number in the range reversed. Okay, let's see what this looks like. Yeah, this is definitely easy peasy so far. There's been a few just new semantics to learn, but it's nothing out of reasonability. I am glad I'm reading the book just for these reasons. I'm also, I'd rather just do that, like specify the whole thing, but that's all right. And then lifetimes happen. Oh, don't discourage me. I'm sure it'll be fine. All right, 3, 2, 1, liftoff. And if we didn't reverse this, we'd go unnecessary parentheses found. Oh. One, two, three, liftoff. But we have to wrap those to scope them so we can call reverse. But everybody knows that you count down from 10. Yeah. And then we could also say if number is 0, then print liftoff and break. Can we just do that? I'm trying to get the semantics down a little bit. Nope. Number is never equal to 0. Okay, yeah, we can. So then we would have to break and add this. Then we have liftoff, and break doesn't need a semicolon, and neither does this. Okay, alrighty. You can use ... equal to include the last value. ... equal. Not. Oh. Okay, so it'd be ... equal 10, and then same thing. Cool. I personally like this better. Yeah, I guess I don't know when I would want to specify a range with exclusive of the upper bound, but inclusive of the lower. Has weird performance issues. Okay. Then I will avoid it. And I will leave a show note to research Rust range 0 ... equals 10 versus 0 ... 11 performance. In general, it's fine, but there was some big stink about an equivalent having worse performance in some cases. I'll have to look into it. That strikes me as one of those things that might get fixed in a future release. And then they'd be equivalent, and then it becomes preference. But if there's any sort of significant or significant reason not to use it, I'll go that direction. But for now, I'll just understand that that's a thing. Okay. In summary, that was a sizable chapter. I learned about variables, scalars, compound data types, like tuples. I think exclusively tuples in this chapter. Functions, comments, expressions for ifs, loops. I want to play with a for loop. If you ever need to do a billion parallel rocket launches, it will be an issue. Understood. It can do something with the fact that a ... equals b is a ... b plus 1, right? Where an overflow can possibly happen. Oh, interesting. Which caused a performance optimization to not be considered. Oh, it had something to do with that. Okay, cool. Great, that makes sense. Okay, so for I is equal to 0. Can we do that? I think we'll have to do let, but I is less than 5. I plus plus. Let's see. Print line I let I is equal to 0. Okay, so it's not going to do that. Expected pattern found let. So for is missing in for loop. There's only the one form of for. Oh. So you must range or somehow be operating on an iterator for 4. Okay, cool. Otherwise you would use loop. Let me look back up through it. Or while. And then do this pattern. Okay. I can dig it. Alright, so let's see. Alright, understanding ownership. Alright, so I'm going to call it there tonight. It is 12:49 a.m. I've got to be up to work in the morning. So thanks. Ownership is honestly the coolest part of Rust. Oh, how long is a chapter? I think I'll need to be more awake to handle that, to be honest. So I'm going to go ahead and sign off. Thanks everyone for hanging out. Go ahead and send me a follow, and we can pick this up again soon, hopefully, maybe within the next couple of days. Thanks for watching.